Hi, my name is Siyuan Xin, undergraduate student from aerospace engineering at University of Michigan. For my summer research, I worked on XHALE shape monitoring system algorithm under the direction of Professor Carlos Sesnik. Just give you a few background. We want the airplane to fly green, fly efficiently, and for certain military use, we want the airplane to fly at high altitude and have a very long endurance, as shown by those two pictures. To meet those requirements, the airplanes are designed to have a very large aspect ratio. So here is our XHALE, which stands for Experimental High Altitude Long Endurance Aircraft. It has an aspect ratio of 30, and the structure is very flexible, which means it deflects a lot during the flight. So it's very important to get the real-time shape monitoring. My job, string gauges are mounted on board, so that my job is to read the output from the string gauge and get the real-time shape. To do this, I refer to Lance Richards' report from NASA. Basically, he just used the linear beam theory and integrated it twice to get the displacement. But in our case, the structure is very flexible. We need to use nonlinear beam theory, which makes the problem more complex. To do the integration, we need to use iteration and assume that the change in slope between two string gauges is linear. However, the code is too slow for real-time monitoring, but the result turns out well. I made an experiment on a steel cantilever beam, as shown in this picture. The result is shown by the plots beside it. The cross dots is the experimental data, and the blue line is the result from the nonlinear code, and the red line is the result from the linear code. As you can see, the nonlinear code is very close to the experimental data. We need to get a new method that can do the real-time shape monitoring. During the discussion with Professor Sesnik, we found this method. Normally, we can get the strings from the curvatures and the axial rating by multiplying by a property matrix. But what if we have the strings from the string gauges and multiply the inverse of the property matrix and get the curvature and the axial strings, that we can use those as input to the nest code developed by Professor Sesnik and Dr. Su and get the real-time shape. I'm still working on this algorithm. Numerically, I have proved that it is feasible. Here is the result that shows when three string gauges are used. And you can see from this table, the error is very close to 0. We still need to do some experiment to prove that this result is feasible. Thank you very much.